So let's look at some examples of where we have a sequence of numbers and the number of numbers increases, and we want to think what happens to the value. So let's take the number n to be a counting number, a positive integer, and it can be 1 or 2 or 3. Now with this animation, as we move the slider from the left to the right, we see that the number of terms we're interested in is increasing. And then the value an is 1 over that number. So we have 1 over 27 if n is 27. Now, if we look at this animation here, n starts off as 2 in this case, and 1 over 2 is a half. Let's increase n. So we've got 1 over 6, and that's 1.66 to 10 to the minus 1, and we see the value is decreasing. Now look at the value of the red dot above the horizontal axis, and you'll see it's getting smaller, but getting closer and closer to the value 0. It's getting smaller. The question is, does 1 over n ever equal 0? Another example is 1 over n squared. And again, if we start with n is 1, 1 over 1 squared is 1. Then as we increase n, the value of 1 over n squared is getting smaller. Now let's look at r to the n, a bit more complicated. Now r is some number whose size is less than 1. So that means r lies between 1 and minus 1. Then n is a positive whole number. So n can be 1 or 4 or 8 and so on. Now let's set r to say 0.48. So it's positive, but its size is less than 1. N is 1, so 0.48 to the 1 is 4.8 times 10 to the minus 1. Now, as n increases, the power increases, the value of r to the n is getting smaller. Let's make r still positive, but closer to 0. And explore what happens to the value of r to the n as n again increases. Similarly, you could look at r is negative and what happens to the value of r to the n as n increases, and what's happening to it in the long term, its value. Now, a common mistake is to say since 1 over n gets smaller and smaller, it must eventually reach 0. Try and think an explanation as to why that's not true, and then click on this tab here to see an explanation of why, as 1 over n gets smaller and smaller, it must eventually reach 0 is not quite right.